Hello everybody, welcome to another Con Support video on creating box plots. So I'm going to show you guys how to do this. It's pretty straightforward once you get used to it. So for the first problem on Con that we got here, it says a list of data here. We got a bunch of data, so let's just do it. You got 41, and then 42, and then 43, and then 43. It looks like they already put this in order from least to greatest. So you always want to put it in order from least to greatest when you start. 45, so that's nice of them. 47, 48, and then 50, and then 50. Okay, so here's our list. Let's double check to make sure we didn't miss any pieces. You always do that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Hey, did I miss something? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I must have missed something. So I have 41, I have 42, I have 43, 43. Oh, I only have two 43s and there's supposed to be three 43s. And that is why you double check and count when you're doing box plots, because you can make a silly mistake like Mr. Fishback just made. So you're going to grab the stuff that's, let's say, over here. We're going to move that over and make space for our 43. We need one more 43 here. So now I've got it right? 41, 42, 43, 43, 43, and then 45, 47, 48, 50, and 50. Okay, very good. So this is an even list, okay? And when it's an even list, what that tells you is you're going to have two values in the middle, okay? Which means that you're going to go through the process where your median doesn't split the data because it's not actually part of the data list. So let's do that. So we look at this, we got 10 pieces of data. That means you've got 4 on the left, which are going to be right there, and 4 on the right, okay, which are going to be right here. And once you've arranged in least to greatest order, you can see the highest 4 can be removed, the lowest 4 can be removed, kind of, and you got these two things in the middle. Now, the reason that we don't have a true median is because these two values are neither of them are the median. The median is actually directly between them. So because it's an even numbered list, you've got to take those two and you've got to average them to get the median, right? So the median is not going to be 43 or 45. It's going to be 43 plus 45 all divided by 2. In other words, what's exactly halfway between these two values? And that would be 44. So your median is 44, okay? So now we understand that the median is 44. That has the name the median, which means the middle value, okay? But the data has been split, and there's a high side and there's a low side. So let's highlight the low side. The low side is going to include the 43 because it's not really a median, so it's included in the low side of the data. And the high side is going to include the 45 because it's also not really a median. The median is 44, so the 45 is included in the data. So now we're going to analyze the low side and the high side to get our quartiles. So the upper quartile is going to be the median of the upper half of the data. So this is nice. There's 5 values. The middle one is going to be 48. That's called the upper quartile. And the upper extreme is going to be the highest value, which is 50. So that's going to be a maximum value or the upper extreme. The lower part of the data, you've got this middle value of 43. We call that the lower quartile, LQ. And the lower extreme is going to be 41, okay? So now we have the minimum value, the maximum value, the quartiles, and the median, which is what we need to make a box plot. So now you're going to put those on our box plot. The box is always from quartile to quartile. So that's what you're looking for. So you're looking for a box that goes from 43 to 48. So that's the first thing I would look for. Okay, this one goes from 43 to 47. I don't like that. This one goes from 43 to 48. That's possible. This one goes from 43 to 48. That's possible. Okay, so we have two possibilities. The A is wrong. And then when we look at this, we want a median of 44, which means we want the line that's going straight down through the box to be at 44. So this one's at 44, and this one's not at 44. It's at 45. So that means that this must be the answer. I don't need to look at the rest of it. If I did, I would see the extreme is 41 and the other extreme is 50. But it's not necessary because there's only one possible answer once I've eliminated the other ones. And there you go. Bing! And let's go to the next one. Okay, so the next problem here is which data set could be represented by the box shown below. All right, so this is kind of a more of an annoying problem because you have to like literally look through all of these different choices and see which one would make sense. The good news is they've already given to you these choices in order from least to greatest, which is kind of cool, right? So it looks like these are already in least to greatest. So let's just first analyze what we can eliminate. This one's the smallest value of 12 and the highest value of 24. Okay, that's pretty cool. So I know that the smallest value has to be 12 and the highest value has to be 24. So that 13 one, that's not a good answer. So that C is eliminated now. The next thing I can look at is, let's say, the middle value. I see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9 values. So when you have an odd numbered list, there is a true middle. So let's find the true middle. 1, 2, 3, 4 removed. The 19 is the true middle. So this looks like it's at 19. So that's a possibility. Let's look at the next one. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so then if we take out 4, 19's in the middle. Yep, that's still a possibility. 1, 2, 3, 4. Oh, this one has a middle of 20 because there's 9 values and the median is 20, which means this one's wrong. So we can eliminate C, we can eliminate D. It's going to be either A or B. So really we're just looking at which one of those is going to be accurate between A and B. Well, let's look at the lower quartile. We go 1, 2, 3, 4 on the left. That's going to be the lower region. And in that lower region, you've got the two middle values of 15 and 17. So the average of those two is going to be your lower quartile of 16. And that doesn't look like it's going to work because this is 16, right? And that's not where the box ends. So I think it's going to be B. Let's check it. 1, 2, 3, 4. Here's our low side, right? Those 4 values are our low side. And so you've got 15 and 15 in the middle, which means that box should end at 15, and that does work. So it's going to be B. The lower quartile is going to be B. Right, and because that was an interpretive one, I'm just going to skip it on the PDF. All right, this one I'll do on the PDF. So this one is a list of data again. So let's do the workout for it. So this is number 3, and it's 4, 5, 7, 7, 7. So 4. Let me write that out so we can all see it nicely. 4, 5, 7, 7, 7. And then it's 8, 10, 8, 10, and then 11, 11, 11, 11, and then 13, 13, and then 14. Okay, let's double check that I didn't miss any data this time. So let's count them up. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of data in our original. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of data in ours. So it should match perfectly. We're good to go. When it's a 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, it's going to be an even list again. So once again, there's no true median. So you're going to 12, half of 12 is 6. So you're going to go 1, 2, 3, 4, 5, 6 on one side, 1, 2, 3, 4, 5, 6 on the other. So that means that 5 values are going to split this thing. So if you're looking for the median, you take 5 from the low side after it's in least to greatest order, take 5 from the high side, and it's going to leave you with these 2 values in the middle that you've got to average. So what's between 8 and 10? That's going to be 8 plus 10 divided by 2, or obviously 9. Okay, so that is what we call our median, or our middle value. It splits the data. But since it's not on the list, now we're going to highlight our low side and our high side. Our low side is going to include the 8, and our high side is going to include the 10. And we have 1, 2, 3, 4, 5, 6 values on the left and 6 values on the right. Okay, fair enough. So now we're going to find the lower quartile, which is going to be the median of the lower half. Because there's 2 values in the middle of this one, let me switch to a pen so I can highlight for you guys. Because there's 2 values in the middle of this one, then we're going to average those to get the lower quartile. So the lower quartile is going to be 7. We call it the LQ, or lower quartile. And then the extreme is going to be 4. That's going to be the lower extreme, or the smallest value, sometimes referred to as the minimum value. On the upper side, you've got 1, 2, 3, 4, 5, 6 pieces of data. So it's going to be the average of the 11 and the 13. That's going to be your median, which is going to be 12. That's your upper quartile, right? The median of the upper half of the data. And then you've got this 14, which is going to be your maximum value, or another word for it is the upper extreme. Okay, so there's your 5 points of data that you need. So you go 4 for the one end, 14 for the high end, and then the box should be from 7 to 12, and the 9 should be where the line goes down the middle. Let's see which one matches this. So we want to go from 4 to 14. So from 4 to 14, that works. This one's wrong, and this one works. Okay, so it's either A or it is C. And then the box is going to be from 7 to 12. So there's 7, there's 12. It looks like this is a good answer. And there's 7, there's 13. So this is a bad answer. So it's going to be A. And then just to prove it, the median should be right down at 9, and it is. So that's it. It's going to be A. And this one, we're going to once again analyze this by looking at the list here, trying to figure out which of these works. So there's some that we can eliminate. So the smallest value is 1, the highest value is 19. 1 to 19, 1 to 19, 1 to 19, 1 to... Okay, can't eliminate anything off the extremes. Then we look at the median. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values. Let me zoom in there so you guys can see a little better maybe. Let me zoom in so you can see a little better. Yeah, you can see a little better now, right? Okay, so there's 11 values because there is a true middle. 1, 2, 3, 4, 5 should be removed from the high side before you get to the middle. So it looks like the middle should be 12 if A is correct. That looks like that's the right one. So that's still a possibility. Over here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 1, 2, 3, 4, 5 off the top. 12 again is the middle. That's still possible. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 5 off the top. 1, 2, 3, 4, 5. And wait, is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that means you're taking 5 off the top. 1, 2, 3, 4, 5. So it looks like 11 is the middle on this one. Sorry, guys, I'm going to hang up on that person. Anyways, so that's not the middle. The middle should be 12. So C is eliminated. And this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's take 5 off the top to find the middle. 1, 2, 3, 4, 5. And I'm just doing that because obviously 5 and 5 is 10, and there's the one extra one in the middle, right? So that's going to be 11 as well. So both C and D are eliminated. They're wrong. So it's either going to be A or B. And we want the box edge, the lower quartile, to be 6. So we want the median of the lower half to be 6. So if 12 is the middle, then looking at the lower half here, you've got 1, 3, 6, 8, 10. Is 6 the middle? Yes. If 12 is the middle, then on the high side, you got 13, 13, 16, 18, 19. The middle should be 16, which would be the top part of the box. Yeah, so A is good. Okay. And that's how you do it. If it's an odd numbered list, right, then the data gets split, and the median is kind of held out separately. If it's an even numbered list, then the parts that's averaged to make the median the low part goes to the low side, and the high part goes to the high side. That's the basic idea.